Data science roles are experiencing severe scope creep. If you apply for a standard position today, you might sit down for the interview and find yourself answering questions meant for a machine learning engineer. For years, the traditional role was contained within Jupyter notebooks, analyzing static data and building models on datasets of maybe 50 to 100,000 rows. But the industry is shifting towards full-stack candidates. This expectation pulls data scientists into infrastructure tasks that used to be the sole responsibility of DevOps and dedicated engineering teams. Instead of just training a model on historical data, you are increasingly expected to design systems that handle real-time inference and manage model deployment at a massive scale. This spectrum illustrates the gap. On the left, traditional analytics. On the right, heavy ML infrastructure. The modern interview planted its flag in the middle. But in practice, that expectation slides all the way to the right, catching experienced candidates off guard. Recently, a candidate applying for a data scientist role at Warner Bros. Discovery made it to the second round, only to be hit with a staff-level ML system design interview focused entirely on deploying models at scale. This scope creep forces working professionals to make a difficult choice. They must decide how to bridge this engineering gap without losing focus on their core data science career. When you search for how to prepare for these rounds, the advice you find is fractured. Many professionals on forums offer a pragmatic approach. Prioritize memorizing specific design frameworks and treat the model itself as a black box. Academic roadmaps argue for the opposite, a deep, multi-month dive into calculus and building complex architectures from scratch. Then there is the third, heavily marketed option, the weekend bootcamp, promising complete AI mastery in just 72 hours. Faced with these conflicting paths, you have to decide which one actually leads to a job offer. The answer depends on your immediate timeline and your personal tolerance for risk, not just the job description. Path 1 is the Generative AI Crash Course. This requires a small investment of time, but it often comes with a high financial cost. In return, you gain a high-level vocabulary and a basic understanding of how to work with existing API wrappers. However, this superficial knowledge rarely holds up under the pressure of a real technical interview. If an interviewer asks how you would handle data drift in a live model, knowing the buzzwords doesn't help you actually diagnose why a model is degrading in production. This path often ends up as an expensive vocabulary lesson with very little technical return on investment. Path 2 is the pragmatic hacker, which is the consensus approach among working professionals. This requires 3 to 4 weeks of intense study, using condensed system design books and drill mock interviews with peers. Within this path, there is a debate over resources, using Alex Wu's book to strictly pass the test, or Chip Hewen's book for a deeper understanding of the practical trade-offs. By the end of this month, you acquire the mental frameworks to discuss the life cycle of an ML system without needing to code the underlying infrastructure yourself. You optimize for the job offer, though you will likely arrive on day one relying heavily on the existing MLOps teams to handle the production engineering. Many major tech companies like Netflix design these rounds specifically to test this high-level awareness of the model lifecycle rather than raw infrastructure coding. This path is designed to secure the offer quickly, provided you are comfortable with the risk of imposter syndrome once you are hired. Path 3 is the rigorous optimizer, the 12 to 18-month academic roadmap. This requires a sustained commitment of 20 to 30 hours a week. You fundamentally relearn multivariable calculus and linear algebra, building complex neural architectures from scratch without helper libraries. This gives you the rare ability to adapt to cutting-edge research and deeply debug systems when they fail at the code level. For example, building your own training loops from scratch ensures you understand the underlying mechanics, so you don't hit an undebuggable ceiling later in your career. However, this massive lifestyle sacrifice is often overkill if you are applying for a standard analytics role. You build a bulletproof career foundation, but you pay for it with your immediate time and energy. Selecting a study path that doesn't align with your immediate timeline often leads to wasted effort, either failing to meet the technical bar or burning out before the interview even starts. This decision tree maps your immediate career goals to the appropriate resources. If you have an interview next month, prioritize conciseness. Use specialized guides and mock interviews to learn how to survive the round. If you want to transition internally over the next year, focus on practical, end-to-end projects that force you to consider real-world deployment trade-offs. And if your goal is to become an AI research scientist, commit to the 18-month roadmap of mathematical foundations and architecture design. The current industry dynamic is for companies to seek specialized machine learning engineering skills while offering a standard data science budget. Protect your time. Ignore the noise and choose the path that aligns with the career you actually want, not just the interview you're worried about.